I'm here to talk today about the kidneys and the urinary system. So, on the agenda today is I'm going to talk about the external structures of the kidney, the internal anatomy of the kidney, the major blood vessels within the kidney, and then specifically in the urinary system, the filtration and the reabsorption slash secretion of fluids. So here are all your vocab words that are going to be found within the slideshow and that you should know for the exam. First up is the external structure. So the location of the kidneys is on either side of the spine, specifically at T12 to L3. And the right kidney is slightly lower than the left kidney just because of um, disproportion. And the coverings, it's covered by three layers. The fibrous capsule, which is closest to the liver, and it is a dense layer of irregular connective tissue. Next is the renal fat pad. It's a layer of adipose tissue that helps to absorb shock. Lastly is the rough renal fascia, and it anchors the kidneys to the posterior abdominal wall. And the supporting structures are your adrenal gland, your ureter, your bladder, and urethra. So the major blood vessels within the kidney are your renal artery, which brings blood to the kidneys. It then branches off to your segmental arteries, and those permeate the kidneys. Then you have your interlobar arteries, and they pass through the renal columns to reach the cortex. And those then break off to your arcuate arteries and your cortical radiate arteries. And then those break off to afferent arterioles, and which service about 1.3 million nephrons in both of your kidneys. And that then flows into your efferent arteriole and into your pretubular capillaries and vasa recta, and those then connect to your interlubrial veins, which return blood to the vena cava. This is your internal anatomy. So, in your internal anatomy, you have the renal cortex, which is the outer region of your kidneys. And then you have the medulla, which is the inner region. And then you have the renal columns, which are like the connective tissue extensions that connect your medulla to the like inside of your kidneys. And then you have your renal pyramids, which you can see right here. And urine flows through those. And then you have your renal palpi, which are like right there ish. And those are bundles of collecting ducts, and you'll learn about those later. And then you have your renal hilum, and it's like the entry and the exit for all the structures that go into your kidneys, specifically like your blood vessels. And then you have your calcites, which there's two of those, the major and the minor, and urine flows through those also. It flows first into the major calcites, and then it flows into your minor. So we then continue on to your nephron, and the nephron is made of two major parts. Your glomerulus, which is on the Bowman's capsule, and your renal tubule. So your glomerulus is a dense set of capillaries that filter the blood based on particle size, and it is lined with podocytes, which interdigitate to form filtration slits and help with that filtration of particle size. And so the next part is your renal tubule, and it's a set of tubes that filtrate flows, so it basically controls how fast the fluids flow. And it's made of three major parts: the proximal convoluted tubule, which is lined with hair-like structures to increase surface area; the loop of Henle, which is also called the nephron loop, and we'll go into more detail about it later in the presentation. And then you have your distal convoluted tubule, which connects to the collecting duct. And right below your glomerulus is, well, right below your distal convoluted tubule is your juxtaglomerular apparatus, and it allows for specialized cells to monitor the composition of fluid within the DCT. And lastly, you have your collecting ducts, which is not part of the nephron, but it's connected to the nephron. And so I wanted to add it on this slide. It is lined with aquaporins, which allow water to pass from the duct lumen through the cells and into the interstitial spaces. So this is your nephron, and it's here shows the three main processes of the urinary system. So one is your filtration system. It's flowing through the Bowman's capsule, and then you have your tubular reabsorption, which is number 2, and you can see it goes into your pretubular capillaries. And then you have your tubular secretion, which is coming from the capillaries back into the Bowman's capsule. So molecules move from the glomerular capillaries into the Bowman's capsule, and just note that hydrostatic pressure pushes and then colloid osmotic pressure pulls. And how to know like the importance of the glomerular filtration rate is that it's based on the three pressures: HPC, which is your hydrostatic pressure of the capillaries; OPC, which is your colloid osmotic pressure of the capillaries; and then HPIF, which is your hydrostatic pressure of the interstitial fluid in the Bowman's capsule. And just know that on average, about 125 milliliters per minute is filtrated in men, and about 105 milliliters per minute is filtered in women. That's just like the rate of filtration through your urinary system. So, and then we move on to reabsorption and secretion. And this is where we get more in depth of the loop of Henle. It's a highly specialized to enable recovery of sodium and water. The reabsorption first occurs in the interstitial fluid, and then it flows into the vasa recta. And the counter current multiplier system basically shows that solute, which is like the sodium in your urine, the pumps increase. So I have a more bigger picture on the next slide. So here's your bigger picture of your loop of Henle, and you can see that as it's flowing down, the H2O is being secreted. So that's your osmosis as it's flowing down your loop. And then as it's going back up, more sodium is being absorbed, and so it's becoming thicker, basically, filled with more sodium and less water. And so that's the end of my presentation. Here's my citations.